Okay, so this is our introduction to probability for our Common Core Algebra 2 unit. So to begin with, there are a couple vocabulary terms that we need to make sure we're aware of and we understand. The first is the word experiment. This is some process that occurs with well-defined outcomes. We know exactly what's going to occur and what are the total options. Number two is outcome, the result from a single trial of the experiment. An event is a collection of one or more outcomes that we're looking for. And the sample space is the collection of all the outcomes that are possible. So exercise number one. An experiment is run whereby a spinner is spun around a circle with 5 equal sectors that have been marked off as shown. So you see 1 through 5, very common spinner for board games. So what is the experiment? The experiment is simply spinning the spinner and noting the number it hits. Landed on the 1 in this example. So to give one outcome of the experiment would be to have the spinner land on any one of the numbers 1 through 5. So on your paper you can write having the spinner land on 1, having the spinner land on 2. That tells me that there are 5 possible outcomes because there are 5 different numbers on the spinner. So then the next question is, what is the probability of spinning the spinner and landing on an odd number? What is the event here? Well, the event is the spinner landing on an odd number. That's what we're looking for. That's the event. The next question is, what outcomes fall into the event? So what is it that we're actually looking for? So we're looking for odd numbers. We need a 1, a 3, or a 5. Those are the only odd numbers on the spinner. So to actually calculate the probability, we would have it written as P for probability, parentheses, then describing the event with which we are looking to occur, and that is to land on an odd number, so we put the word odd in here, equals, well, there are 3, 1, 2, 3 different outcomes that we're looking for out of a total possible 5. So my probability is 3/5. So our answer there helps us to define the basic formula that dictates all probability calculations. So as you've seen before, the probability of an event, and we can just call it E for event, occurring is given by the ratio P, or probability of E, equals N of E over N of S. And so down here in our key, it will describe what each of these represent. N of E is just our successes. That's the event that we're looking for, the number of outcomes that fall into the event. In the last case, it was odd numbers. N of S is the total number of outcomes. Those are just how many total that could possibly happen. Exercise number 2 asks us, given the above definition, between what two numbers must all probabilities lie, and explain in some fashion. Well, it has to fall between 0 and 1. There's lots of ways that you can explain it, but the most important is that it has to be a positive number because we're counting the number of ways that things can occur. And when we look at possibilities, in this example we had 5 possible outcomes. Well, the only things that could occur are 1 through 5. We can't have 6 different possible options when there were only 5 to begin with. So the highest our probability could be would be 5 out of 5 in this case, or we would say that with the number that we have on top, it just gives us a probability that is going to reduce to less than or equal to 1. Think of it as 100%. So now we're moving on to theoretical probability. That is specifically what we've been working with, and that's dealing with theory. We don't actually have to run the experiment. I didn't actually have to flick the spinner on the last example to determine the probability of an event. We simply have to know the number of outcomes in the sample space and the number of outcomes that fall into our event. Let's take a look at a slightly more challenging scenario. On example 3, we're going to work with a coin, and we're going to assume it's a fair one. It's not weighted improperly at all. A fair coin is flipped 3 times, 3 whole times, and the result is noted each time. The sample space consists of the ordered triples. And one example is HHT. That's how it's written. So what that means is that we'd have a heads on the first toss, a head on the second toss, and then followed by a tail on the third toss. That's heads, heads, tails. So we're asked to draw a tree diagram to show all of the different outcomes in the sample space. So this is where we begin, this point right here. In some cases we put the word start to remind ourselves that we're starting right here. And so when we flip the first coin, we either will flip a heads or tails. And then after, say we flipped a heads, we're going to pick up the coin and we're going to flip it again. We could get a head or a tail. From there, I could throw my coin one more time and get a heads or a tails, a heads or a tails, heads or a tails, or heads or a tails. So this represents all the possibilities of me flipping the coin 3 times. Part B asks to list all of the outcomes as ordered triples. So that means we would write H, H, H to represent heads, heads, heads. Then heads, heads, tails, heads, tails, heads, and so on. So once we list all of our triples, our ordered triples, they'd like to know how many of them there are. Well, we can count them here, and there are 8. Or we can count the final branches of our tree diagram. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 branches. Each one of them represents each one of our ordered triples. Okay, so feel free to pause the video at this time to make sure that everyone has a chance to construct the tree diagram and list all of the outcomes if they haven't already. So I'm going to keep going, but again, please feel free to pause the video as needed. Moving on to part C. Find the probabilities based on your answers from parts A and B. So the first question is the probability of all heads. Well, there was only one way we were going to get all heads, and it's listed in both areas. So there's 1 out of a total 8 possibilities. So we have a 1/8 probability. Probability of exactly 2 heads. Well, that's exactly 2 heads, not at least. So that means the heads, heads, heads option is not included in our successful outcomes. So we have heads, heads, tails, heads, tails, heads. That one's no good. Here we go, tails, heads, heads. So that's 3 combinations where we have 2 heads exactly. So we have 3/8 as our probability. Our third one here, probability of all heads or all tails. We'd be fine as long as we get 3 of a kind. So how many different ways can we get exactly 3 of a kind? Well, that has to be a heads, 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 or tails, tails, tails. So that's 2 possible combinations out of a total of 8, which of course would reduce to 1/4 probability. You can just count up the options, or we could find the probability of each combination and then add them together. We get the same answer either way. So that's theoretical probability. Sometimes we have to quantify chance by observing observations that have been made in the real world. In this case, we talk about empirical probability. The fundamental equation for probability still stands. So here's an example of that. A survey is done by a marketing company to determine which of 3 sodas was preferred by people in a blind taste test. The results are shown below. So that results are listed right in here. There's soda A, B, and C, and then the number of people that preferred each one, with a grand total of 53 people involved in the survey, in the blind taste test. Find the empirical probability that a person selected at random from this group would prefer soda B. So we're looking for the probability of preferring soda B. So we come over to our table. We see that there are 24 that prefer it. So it's 24 over 53. That fraction is as reduced as it's going to be, so that's our probability. They also ask us to not only express our answer as a fraction, but also as a decimal accurate to 2 decimal places. And that is pretty much the standard for probability. So when we divide on the calculator, 24 divided by 53, we will get this glorious number. And of course, when we round to 2 decimal places, we will just get 0.45. That is essentially 45% of the 53 individuals included in this blind taste test prefer soda B. That does not suggest all of the community, all of the population has the same preference. It's just about those 53 individuals. So then we're going to find the empirical probability that a person selected at random from this group would not prefer soda A. So what does that mean? To not prefer soda A. That means you're going to prefer soda B or C. So when we find our probability of not soda A, I'm going to come to my table and find not A, but B and C. That's 24 and 11. We're going to add up all those people that do not prefer soda A and divide by our total. So our reduced fraction is 35 over 53. And when we divide on the calculator, we get this decimal, which would round to 0.66, which is about 66% of our data set of 53 individuals. Now you can go on to work on your homework.